Hi friends, this is team group 1. We are here about to say the traversal algorithms. Our teammates are Chandrakant, Harika, Krishna, Rakesh, Priyanka, Ramya, Pawan, Kasireddy, Nachketan Reddy. And in this PPT, we are going to explain about the path traversal algorithms or the pathfinding algorithms. Basically, pathfinding algorithms are built on top of the search algorithms to explore the route nodes between the starting and the destination node. This goes through traversing from all the graph and evaluating the relationship between each nodes. These algorithms find the cheapest path in terms of uh, cost, capacity, time, and distance, etc. Further, my friend will be going to explain you about this thing.
Yeah. Coming to the next slide. Yeah, these are the flow of the information we are presenting today. This is the introduction, breadth first search, depth first search, greedy best first search, uniform cost search, and A-star search with the local beam with k equal to 2. Coming to the next slide with the introduction. It basically consists of the search algorithms. In the search algorithms, it was the informed search, uninformed search, and informed search. Uninformed search basically consists of the depth first search, breadth first search, and uniform cost search. And in the coming to the informed search, it consists of the greedy search, A-star search, and graph search. Coming to the next slide. Here is the travel map. This is an undirected graph in this the heuristic value of the graph is of the A is 16 and B is 12 and N is 12, and the cost from A to B is 5 and cost from A to D is 5. Cost to reach from one node to another node is given on the edge. So to calculate, we need both of them. The cost function is calculated in the uniform search and the greedy search. From the next slide, my friend Harika will continue.
Yeah, hi guys. I'm discussing breadth first search algorithm. In this, it expands the nodes in its first level, and after it moves into next level. And also the BFS algorithm works on the FIFO queues. So first in, first out rule. And the space complexity also the same as the time complexity. In this BFS algorithm, all the nodes will expanded level by level in this. And explaining algorithm also. Next slide. For algorithm for BFS, the first step is for the start node, any node will be choose. And also step 2 is the its visits its adjacent unvisited node. And the third step is mark as visited node in the Boolean array, and it will be displayed. And next, insert the visited node into the queue. If there is no adjacent node, remove the first node from the queue. And same repeating the same steps after queue is empty. And explaining the example given. Next slide. We started with the A node. This will be the output. A goes to B, and the B, N, Q, S, X, H, Z, K, F, E, and J, M, Y, L, P, D, U, T, G. This will be the BFS algorithm, the shortest path. So next will be continued by the Pawan.
Can you guys hear me? Hello?
Yes.
Yeah, we can hear you.
Yeah, good afternoon, everyone. So today I'm going to discuss about the depth first search. So it is a reverse algorithm for searching all the vertices of the graph or a tree data structure. The traversal means visiting all the nodes of a graph. So this algorithm starts at the root node and explores as far as possible along each branch before the backtracking. So here the word backtracking means that when you are moving forward and there are no more nodes along the current path, you move the backward on the same path to find the nodes to transfer it. So all the nodes will be visited on a current path till all the unvisited nodes have been traversed, after which the next path will be selected. So for the depth first search, the complexity will be the time complexity of this DFS will be the O of V plus V, V plus E, where V stands for the vertex and E stands for the edges. And the space complexity is also is an extra visit array of size with V is required. So the next slide will be the depth first search algorithm, how the algorithm works from the node to node. So the implementation puts within the two categories. One is the visited, one more is the not visited. The purpose of this algorithm is to make each vertex as an visited while avoiding the cycles. So the algorithm works in the 4 steps. The first step will be by putting any one of the graph vertex on a top of the stack. So the step 2 will be the type item on the stack, and it adds to the visitors list. And the step 3 will be the list of all the vertex adjacent nodes and the one which are not in the visitors list to the top of the stack. And the step 4 will be the it repeats the step 2 and step 3 until the stack gets to the empty state. So the next slide will be the uh, can you move to the next slide? So next slide will be the implementation done on the Python in the Python way, and the output for the different nodes starting with the K followed by A, B, and S. So for the K, the output will be starting from the for the node starting with K, it travels to the K followed by J, D, T, G, U, L, E, H, Q, B, A, N, X, FM, Z, S, P, Y. So in this way, for the different nodes, the travel path will be based on the above search logic steps from the step 1 to step 4. And the next algorithm will be a greedy, and it will be showcased by the Ramya.
Yeah, thank you, Pawan. And coming to my slides, I'm going to discuss about the greedy best first search algorithm. And this is one of the best first search algorithm, as it is a combination of both BFS and DFS. In this, mainly the priority queue is used to implement this one. And this is also known as a greedy search. And in this, we uses the heuristic functions, and it is also known as a heuristic search functions. In this, it always selects the path that it appears to be the best at that moment. In this, it searches and uses the heuristic function, and it combines both the benefits of the both BFS and the DFS. In this, we extend the nearest node to the goal node in the best first search, and the nearest node to the goal node is the closest cost that is determined by using f of n equal to z of n. And we can see here the time complexity and the space complexity is same for this greedy best first search algorithm. And now we are going to see the algorithm and how we are going to implement this. In these first steps, we are first implement our two empty lists, that is one is open list and the closed list, and starting from its initial node, and it is called to be an n, and then it put it in an ordered open list and then repeat until the goal node is reached. And if the open list is said to be empty, then exit the loop and then return the statement false, and else then select the top node which is called as n in an open list, and it is moved to the closed list, and as it takes all the information present in its parents node, and where here we choose an n is called as a goal node, then the node is moved to the closed list, and it will exit the loop by returning the statement true. And in this, we use mainly the backtracking of this path to find its appropriate solutions. In this, we follow an ascending order to calculate and evaluate function f of n. In this, the node should be reordered in an open list. And coming to the next slide. This is the output for the code that we run in Java. In this, its start node is A and the goal node is G, and we can see the output here. Yep. Thank you. Next will be continued by Priyanka, I think.
Hi everyone, today I am going to discuss about uniform cost search. Now, in this search, the node with the low cost gets expanded first, and then cost of every code can be calculated using the formula, the given formula. In other words, the uniform cost search algorithm can be explained as it uses the lowest cumulative cost to find the path from the source node to the destination node, and nodes are expanded starting from the root according to the minimum cumulative cost. And the uniform cost search is explained uniform cost search is explained using it's implemented using the priority queue, and its time complexity and the space complexity are the same. Next slide. Uniform cost search algorithm is carried from below steps. First step is it uses for uninformed cost search. First, it insert the root node into the queue, and next, the inserting the nodes into the queue will be continued till the queue is not empty. Next, we have to remove the successor element with the highest priority from the queue. If the node is a goal node, then we have to print the cost and the path and exit. If it is not the goal node, then we have to continue the loop, insert all the children of the removed elements into the queue with the cumulative cost with following the priorities. Next slide. Next slide. In the next slide, this is the output of the code we have run. Here we have taken the start node as A. So UCS nodes visited in the order A to B to and to goal node G. This is the sample output, and the next will be continued by my teammate.
Hi friends, my part is about A star local bean search with k is equals to 2 value. Basically, A star search is the best optimal solution for an A star algorithm which combines uniform cost search and A star search to get the optimal value of the local values. Beam search is a heuristic search algorithm that explores a graph by expanding the promising nodes in a limited set. Beam search is an optimization of the best first search that reduces its memory requirements. Basically, A star with local beam search is an hill climbing handling problem. It only evaluates limited set of uh, successors with according to the constraint of the A star search. Coming to the algorithm, first a state is selected in the A star search. Next, all the successors of one root node are kept into the successors list, and the explored list the nodes which are explored are kept in the explored list. Next, the heuristic value, the cost function is calculated with the help of the heuristic value and the cost between the two paths, and only the least values of the nodes are selected and other values are discarded. After that, the same goes with all the explored nodes. The successor nodes are kept in the successor nodes of the explored list, and the cost function is calculated again. In this way, until the end goal node is reached, the path is selected and every other thing is discarded, and it returns the path according to the best selected successor. And coming to the A-star local beam output, this is the code we have run in Python. And if we start with the start node A, the path would be like A N X Z M L U G. This is the path when coming to the start node as A, and the successor becomes M. In this way, the shortest comes with the A-star beam search algorithm. Uh, yeah, coming to the challenges, my friend will be coming to explain.
Hello, good afternoon, everybody. We are facing some of the challenges while doing the project. The main four challenges are like errors when we are setting up the Java and Python environment. Like we have faced in a compiler time error, runtime error, and logical error. We have solved it by doing like we have tried an offline installer, and we have uninstalled any non-working Java installation, and we have restarted the browser. And the next one is like issue executing in the Python and Java. Uh, Including the graphs and the integrate using the alphabets. We have faced it. Like, and next part will be continuing.
Yeah, in conclusion, we have tried to implement each and every the search algorithms which we have been given, and using various like languages and all, using the structures which have been given to us, like linked list queues, stacks, and priority queues as well. And in conclusion, like our team members rose to the occasion and perform excellently with a great coordination. Pathfinding is closely related to the shortest path problem within the graph theory, which examines how to identify the path that best meets some critical criteria, like the shortest or the cheapest, the fastest, between the 2 points in a big large network. In conclusion, we got a chance to apply our knowledge of data structures and traversal algorithms in a real-time situation. Thank you.